Welcome to Sundar's lecture. This is lecture number 89, and in this lecture we are going to see numerical problems related to two-port network, right? So what are the topics we have seen in the previous class? We have taken the reciprocity conditions for all the parameters, which means Z, Y, H and ABCD parameters, and we have derived the expressions, right? I think this is the condition for reciprocity if it is a ABCD parameter, and all other parameters we have found what is the reciprocity condition, right? Now in this class we will take some problems, right? So problem number one, we need to find Z parameter of the circuit, and the circuit is given like this, right? So what will be the Z parameter, and we know the expression for Z parameter. What is the Z parameter expression? I will just write it down. So now you see this is the expression for Z parameter, right? So we need to find what is V1 and V2. If you find what is V1 and V2, then obviously you can get this one, right? So you can easily get Z1, Z1, 2, 2, 1, 2, 2, everything you can get. So now this is I1 that they have already given you, and this is I2 that is also they have given you, right? And the current directions are this one and this one. We know everything already, and there is no problem with that. So now what will be the current flowing through this resistance? So this will be, maybe I will take a different color so that you can easily see. So this current will be I1 plus what is this one? I2. Right, because this current is coming in this direction, so apply KCL, obviously this current will be I1 plus I2. Right, now what you do, this is the first loop and this is second loop. The current direction is like this and this current direction is like this. Obviously you try to write the KVL expression, then you can easily get the values of V1, right? If you want to find what is V1, please try to refer my previous lectures. What is the, how to write the expression for voltage between any 2 points in a network. I will just add that video lecture link in the description. So start from minus and end up in the plus. So we will get V1, right? So V1 will be is equal to, V1 will be is equal to, see I will start from this point and then I am coming, the current is coming opposite to me. So what I will get, it will be 4I1 plus 4I2. Right, and then you are going in this way, again current is coming opposite to you, so it will be plus 3I1, right? Now if I consolidate this, what is the expression? So V1 will be is equal to 7I1, right? So 7I1 plus 4I2. Now this is the expression number 1, which means we have found this expression. We have found this expression. So what will be Z11? It is very easy to write the answers, because what is the Z11 now? So Z11 will be is equal to 7, comma Z12 will be is equal to 4. There is no difference. It is very easy. Straight away you can get the values, right? So now what we will do, we will write the KVL for this loop, for the second loop. Maybe this is KVL at loop 1, and now we try to write the KVL at loop 2. See, current direction is like this, right? So if you want to get what is the value of V2, start from minus and end up in the plus, right? So V2, so start from this point, so the current is coming opposite to you, so what is this value? It will be 4I1 plus 4I2, that is the same one. And then you are just traveling opposite, this current is coming opposite to you, so you will get plus 4I2 plus 4I2, and then you are traveling from minus to plus, right? You are traveling from minus to plus in this voltage, so it will be plus 4V1, right? This is the expression. So now if you simplify this, there is 1I1 and maybe V2, which is equal to 4I1 plus, see this one will be 8I2 plus 4 into, what is V1? What is V1? This is V1, right? Because we don't need V1 here. We need only I1 and I2. So replace this V1 and V2. So this is 7I1 plus 4I2. So if you further simplify this, V2 will be is equal to 4I1 plus 8I2, and then it will be plus 28I1 plus 16I2, right? So this will be the expression, and if I finally write, V2 will be is equal to, here there is one I1 and this will be 32I1, and here it is I2, right? So plus 24I2. So now this is expression number 2. In sense, what we have found, now Z21 will be is equal to 32 and Z22 will be is equal to 24. That's all, right? So now we have found Z11, it is 7, and then 4, and then 32, and then it is 24. That's all. Now this is the Z parameter. This is the Z parameter. See, it is very simple problems, right? We have found the Z parameter of the circuit. Maybe if they are asking you whether this circuit is reciprocity or it is reciprocal, no, right? What is the condition for reciprocal? If you have a Z parameter, see, if it is reciprocal, if the circuit is reciprocal, then Z12 should be is equal to Z21, right? Whether this condition satisfy here? No, right? No. Z12 is a different from Z21. It is 4, it is 32. Then obviously you can write this circuit is not reciprocal. It's not reciprocal, right? You can easily get the idea, right? Now we will go to the second problem. Now you see, this is the second problem, and we need to find the value of H parameter, right? What is the H parameter? I will just write down the expression here. See, I have just taken the expression for H parameter, and this is V1 and I2, and in combination of I1 and V2, we have seen these kind of things already, and I'm not going very deep into that. Anyhow, we need to find V1. How will you find V1? Now, it is also very simple, right? So this is first loop. Maybe you take this is a single loop, right? You can apply KVL at this particular loop. So I will write it down, KVL at loop 1. Maybe I'm just writing loop 1. You try to understand this is loop 1, right? So what will be the expression if you're writing V1? So start from minus and end up in the plus. So from minus, I'm just going in this way, there is nothing connected, and I'm coming here, the current is coming opposite to me, so it will be plus 5 I1. This is given. See, I1 5 ohms V1, and this is 4 ohms V2, I2 0.4 V1. Everything is already given. It is in the question, right? So now V1 I have written. So that's all, right? This is expression number 1. And what is H11 now? What is H11? H11 will be 5. And what is H12 here? H12 will be 0. There is no H12. There is no V2 term in relation to V1. So it will be 0. Then what we need to find? We need to find what is the value of I2. This current you need to find. Right? Maybe if I take this as a node, and I am just taking this current to be X. I am just taking myself, right? So what you do? You try to apply KCL at, maybe if I am taking this as node A, at node A. Then what will be the current? This current is coming here, so it will be 0.4 V1. Maybe if it is more, then they are representing that it is the value of current direction. Maybe this is the current source, right? Dependent current source that depends on V1, and we have already seen what is dependent sources and how we need to solve the problems for dependent sources. Everything I have already solved, right? So now this is the current coming in, it is this one, and the I2 is also coming in, so it will be plus I2. And this X, I am just taken this X to be going away from this node, so minus X, and that should be is equal to 0. Right, now we know what is V1. We have already got the value of V1, right? So this is V1, right? 5 into I1. So 0.4 into 5 I1 plus I2 minus X equal to 0. And if you simplify this, so what I am getting, it is 2I1 plus I2 minus X equal to 0. See, I need the value of I2 and we need to replace this X, right? So maybe if I write I2, if I write I2, I will write it down. What is I2? Then I2 will be is equal to minus 2I1 minus 2I1 plus X. Right now, what is this expression? See, I have got H21 I1. So I1 in I have got an constant value that to be that we can take it to be H21. But I need to get what is the value of V2, right? We need V2 here. But I have X here. So how will you find V2? It is very simple, right? So again, if you want to find what is V2, start from this point, go in this way, come here. You will get V2, right? Can I write the V2 expression now? So V2 which is equal to, so start from minus, I will come in this way. See, I have to go in this way. This current is coming opposite to me, so it will be plus 4x. X is the current, right? So then there is nothing connected. I have reached this point. So V2 to be V2, I can write it as what? 4x. So in sense, this expression can be further simplified. X will be is equal to V2 by 4. That's all. You just simply you just substitute that in that expression. So it is minus 2 I1 plus V2 by 4. What is the value? It will be 0.25 V2. That's all right. We have got the expression now. So I2 will be is equal to minus 2 I1 plus 0.25 V2. That's all. You can compare these two expression now. And what is the value of H21? It is minus 2. And what is the value of H22? It is 0.25. Right? Right. We have found all the parameters H11, H12, H21 and H22. That is what the question is. We need to find the H parameter. Right? So we have found all the values. Right? And if they are asking you whether this is reciprocal and what is the condition for reciprocal, if it is H parameter, then it has to be H12 should be is equal to minus H21, and it is not in this case, right? So you see H12 is 0 here and it is minus 2, it will not be same, right? Anyhow it will not be same, and this circuit is not a reciprocal circuit. That is what we need to conclude here, and we will take another problem. And this is the third problem, and we need to find Z parameter and Y parameter, both. We need to find the both parameters here. See if a circuit is like this, then it is very tough to go. This is loop 1, loop 2, loop 3. There are so many things, and we need to consider and current flowing through this branch, and it is very tough, right? So for this, what you do, you just convert the star now. This is star connection, and if you convert this, you will get a delta connection. And if it is delta connection, then it will be easy to get down the expressions with I1 and I2. You can apply nodal voltage analysis method. So we will get Y parameter. From Y parameter you take inverse, obviously you will get the Z parameter. That is the easiest way to approach these kind of problems, right? If you see any problems like this, try to convert this star to delta connection. So, right, I will draw the diagram and I will directly convert the delta version from the star, and you just try to convert it by yourself, and I will put the lecture links in my description to convert star to delta. And for examples, we have solved many problems for solving star to delta conversions in our previous lectures, right? You take and see how to solve, how to convert a star to delta connection, right? And now you see I have just converted this star to delta connection, and now see this is node 1 and this is now node 2. So we can easily write the matrix form, right? Very simple. How will you write the matrix form? So I will just draw the diagram. Sorry, write the expression. So there are 3 nodes connected, 7 and 25, 7.14. So what is y11, it will be 1 by 7 plus 1 by 7.143, and then plus 1 by 25, and then what is the uh, common resistor? It will be minus, both resistance are there, there are two common resistance. Maybe if we simplify this, you will get the values anyhow, you try to get like this, right? So it will be 1 by 7, so it will be common minus, so minus of 1 by 7 plus 1 by 7.143, and this will be like this, and then again the common, it will be minus of 1 by 7 plus 1 by 7.143 is there, and then y22, there are three resistance again connected, that is 1 by 7 plus 1 by 7.143, and then plus it will be 1 by 12.5. Right. This is the matrix, and what should be multiplied here? So this will be multiplied by V1, that is V1, and V2 is the unknowns, and this will be equal to I1 and I2, right? If you simplify this, you can easily get the values of I1 and I2. So I will simplify and write down the expression. So now this is the simplification. See, we are getting this matrix format, and you can easily write down the expression. Now what will be I1? It is 0.32 into V1 minus 0.328 into V2. So I will directly write the value of I1. So I1 will be is equal to 0.32 V1 minus 0.28 V2, and that will be I1. So this will be 1. This will be expression number 1, right? So I will just write it down, and if you are going for I2, then what will be I2? It will be minus 0.28 V1 and then plus 0.36 V2, and this will be equation number 2. This will be equation number 2, and this will be equation number 1. And you see this one, what is y parameter? Y parameter will be is equal to what? Maybe I will take this to the next page. So I have taken this to the I1 and I2. What is y parameter? It is I1, which is equal to y11 V1 plus y12 V2. That is the first expression. And what is I2? It is y21 V1 plus y22 V2. And you can now very simply write the values of y11, y12, everything we have got, right? What is y11? It is 0.32, and y12, it is minus 0.28, and y21, it is minus 0.28, and y22, it is 0.36, right? So now you see we have got y parameters, and whether the circuit is reciprocal? Yes, it is reciprocal. How? What is the condition for reciprocal? It is y12 should be is equal to y21, right? You see both answers are equal. So what we can conclude here, this circuit is reciprocal, right? We can easily get the idea from this particular example. And what they have also asked you to find, they are asking you to find the z parameter, right? How will you find z parameter? Very simple, right? The z parameter can be the inverse of y parameter. We have seen this one, right? So what is y parameter? We have got y parameter we have got it to be 0.32 minus 0.28, and then this is minus 0.28, and this is 0.36. Right now, if you take inverse of this, then that will result in Gz. Right? So how will you take inverse of this particular matrix? right? We have seen these kind of things already. See how to take the inverse of a matrix of a 2 for a 2 cross 2 matrix. See, I have explained you anyhow everybody knows how to take the 1 minute. See, we have seen here, right? So what we need to do, we have to inverse these two. We have to inverse, maybe we have to replace, not inverse. We have to replace these two, and these two has to be written in minus values. Has to be written in minus values, and this one will be the determinant value. Multiplication of these two minus of these two. We will get this exact values, right? So these two has to be replaced with the both signs, and these two has to be reversed, maybe replaced, right? Both has to be reversed. So what we will get, so z parameter, z value will be 1 by I have to multiply these two, 0.32 into 0.36, right? I will get, so I am getting 0.2, sorry, 1216 minus of, and we need to multiply these two. So if I multiply, I am getting 0.0784. This is the value, and this matrix you have to reverse these two, so it will be 0.36, and here it will be 0.38. Both, sorry, not 38, it is 32, 0.32, and the signs has to be reversed, so it will be 0.28, it will be 0.28. So what you need to do, you just minus these two answers and multiply everything with this term inside the matrix, and finally we will get z parameter, right? So I will directly write the z parameter value here. See, 1 minute, I have made a mistake here. See, this value, if you multiply 0.32 and 0.36, I am getting 0.1152, 0.1152. This value 0.1152. Maybe if I multiply these two, 0.28 into 0.28, I am just getting 0.0784. This is correct, right? So I made a mistake. You just change this down, and then I will write the final expression, and you see we have got the values. Now this will be, what is this value? Maybe I will write it down, maybe in a different color. So Z11, which is equal to 9.78, comma Z12, which is equal to 7.61, and Z21 also it is 7.61. Maybe I will get it here, and then Z22 will be is equal to 8.69. See, again, whether the circuit is reciprocal, yes, it is reciprocal. How this is reciprocal? Because Z12, which is equal to Z21, that is the condition, right? We have seen these kind of things already. See, you try to understand. I am not asked those kind of things in the question. So this is satisfying here. So again, this circuit is reciprocal. That hence it is proved in both the cases. Z12 and Z21 is equal, and Y12, Y21 is equal, right? So what we have seen in this particular lecture, we have taken three different problems. First problem, we need to find the z parameter with the dependent sources given in the question, right? So what is the equation for z parameter? We need to write v1 and v2 in with respect to i1 and i2, right? That is what we have seen it as the z parameter, and we have solved the problem and we have got the z parameter, right? So you just write the KVL expression for this loop and this loop, that's all. And then for the second problem, we need to find the h parameter, and if you want to find h parameter, then we need to write the expression for this one. So v1, it is very simple to write the KVL expression and apply KCL at this particular node, get what is the value of i2. That's all. We have found the h parameters here. And if you see any problems like this, if they are asking you to find z and y parameter, and if you want to find the problem answers, then you need to convert the star to delta, and I have done that. And then what we have seen, what we have done, we have just applied KCL at these two nodes, and we have written the expression for I1 and I2. and we have got the y parameter straight away, and then we have taken the inverse and we have got the z parameter, right. So this is how you need to solve the two-port network problems, right. Thank you. We will see in the next class.